Hey everyone, welcome to the first episode of season 3 on the @ITS Now YouTube channel. We've got some really great programs coming up over the next few months, so make sure to subscribe to the channel. You don't want to miss seeing these very varied videos we've got lined up for you. In this episode, we're going to look at Signal Studio from Traffic Group Signals. This won the second prize in our 2023 @ITS Now Innovation Awards, and I'm delighted to have had an opportunity to sit down with Darren Hudson from Traffic Group Technology to discuss it whilst he demonstrated some of its innovative features. This sophisticated and capable software configuration package, which is used with their Metro temporary traffic signals, provides a wealth of features which in some extent outperform the capabilities of the packages used with permanent signals. Anyway, I'm Alistair and this is @ITS Now.
Yep, I'm Darren Hudson. I'm Senior Project Manager at Traffic Group Technology.
Brilliant. So, what are we looking at today?
So this is Signal Studio, which is our PC-based design software for both temporary and portable signals that are in our Pro range. So this is taking signaling on from the sort of more simple phase-based temporary solutions into the world of sort of grown-up stage-based, much more like permanent signals,
Yes.
kind of signaling.
Yeah, so I think, when I've seen this previously, I was really impressed by the capability and the contrast between previous implementations for temporaries and portables. It's just, a huge sea change. It's such an advance on that. But actually, also compared with permanent signals, actually some of the capabilities in this software package are really impressive. So it'd be interesting to for our viewers to have a look at that and see what's going on in this.
Yeah, absolutely. Yeah. I mean, the motivation here was the fact that we were moving from a space where we just input red or green times to a portable signal controller to now having a vast array of settings and configuration if we're moving more towards permanent signals. So we kind of had to create this software to make that process sort of quick and error-free, because the sort of temporary traffic management industry runs at a blistering pace really, so we've got to sort of keep up with that. So that's in a sense why I put so much effort into making it
I think
quick and efficient, I suppose.
Yeah, so I think that's really important to stress that if I were designing a signalised junction, that might take weeks or longer, depending on the complexity we're looking at, to actually design and make sure everything's correct. So having to do this at just a few hours notice sometimes, I can really see how this tool will help.
Yeah, absolutely. Yeah. Okay, so if we have a sort of brief tour. So we start out with a traffic management drawing that's supplied to us. It's often, say, a PDF, which we can just drop in, import into the software.
Yeah.
And we can dial in just how bright that is in the background, so we can draw over the top of it.
Yes.
Kind of guiding principle. Obviously, we can add phases and stages to the scheme, and
then different types of phases as well.
Right. Yeah. And then we can add signals from basically a library of different types of physical pods, as we call them here, that we know the product supports.
Okay.
So that's one of the other key things about this software. It knows exactly what our products can do. So it really sort of holds your hand all the way through. So you pick one of those, which appears on here with a symbol, and then we can move those around on the map and orient them. We can come in and look at the settings on those, make changes to them.
Yeah, so you've got really have got full visibility of what each of these is and really tweak it to get exactly the requirements for that site.
Yeah, so we can adjust radars and we can put regulatories and things on, substitute arrows.
Yeah.
So we build all of that up. Probably the next thing is a schematic. You can do this in different orders. We've tried to leave it flexible to different designers think in a different way round.
Yeah. Yes, certainly some people will be very much looking at stage sequence first. Others will be really detail oriented on where the poles are and what poles you need. Yes, so that flexibility is really good.
We often start with this sort of where the poles are because we've got so many limitations as to where you can actually put a base down.
Yes.
Given that we're only there temporarily.
Yeah.
So
and you've got to allow for rent of
the space.
Yeah. Although you haven't got the issue that permanents have with actually trying to find an area of tarmac that hasn't got a load of services underneath.
Yes,
We're going to put the pole in. So yeah,
we have that benefit at least. Yeah. So we tend to draw this schematic on next. So pick a suitable arrow and a phase letter, and then that would appear on here, and we can sort of drag those around. Fairly sort of standard stuff. So draw that out, and then conflict matrix. This is a very simple conflict matrix.
yeah,
But on more complex sites, as you whiz through here, it highlights the pair of phases
right.
that you're looking at, and you can just double click one of those to turn it to a nice green tick.
And if you put a red cross in there for conflicting, will it automatically put the paired phase in on the other side of the diagonal as well?
Yes, yeah. So this is symmetrical.
Yeah.
And there's some other things built in. So once we've designed this, it then effectively puts the sort of armbands on you in terms of designing the stages. So it will prevent you putting anything conflicting in here. So we design the stages by just ticking the tick boxes against each stage. This is a bit of an interesting scheme because it's very spread out, and we didn't like the idea of running traffic through some of these distant pedestrian crossings.
Yeah.
So we're running each pedestrian crossing just after its most sort of closely associated vehicle head, which just sort of feels safer.
So you're happy that last traffic flow is cleared.
And it's going away from the ped that we're now going to service, which is where we see a lot of temporary schemes with long shuttles has been a bit of a safety issue.
Yes.
So then you can, again, this is a very simple example. You can choose the demand makeup for the stages. Perhaps.
Well, with this, mostly
it's just one phase in each stage.
Will demand it. But if you've got phases appearing in multiple stages, you might not one of those phases to demand stage 2 or something. It just
and we can do things like walk with traffic. See a quick example of that later. A walk with traffic stage where it's just demanded by the ped and it's only there for the benefit of the ped. So that sort of thing happens there. We can block particular stage transitions. We've done that here actually to force the stage order. As I just discussed about where the peds are run. Yeah. So in the middle of the night, it can't shortcut that and run it out of sequence. So that's built in there.
Remember to hit subscribe for ITS now.
Some fairly basic timings. And then we get into the sort of, I think the bit that is a bit more the wow factor when we get to the intergreens.
I've been looking forward to having a look at this.
Before we get there, I will show you something else actually, which is the calibration. So because we don't necessarily know what what the scale is of these drawings, and we sometimes even get drawings that the X and the Y scale isn't actually the same, which seems surprising, but it has happened.
Yes.
So you draw these calibration lines on, and the system cross-checks them. So if they were inconsistent, it would flag that. So we've now got a calibrated sort of map. We draw the pedestrian crossings on. So we just add one of these and just position it onto the map.
So in this example, we can see that this is the position for the temporary crossing facility. We can see the sort of zebra line of a previous crossing, but it isn't actually where this one is going to be whilst the works are being carried out. I think sometimes people get a bit confused looking at some of these things and think, oh, they've got that wrong, but actually, no, it's because they're doing works in the other locations.
That's right.
So
you do have to go to great lengths though to stop people trying to use those old crossings. You've got to put a lot of barriers up to really keep people away from them. So yeah, that's really important. So we've drawn the crossing.
The intergreens and things that would have been on the permanent won't be applicable to these locations anyway. So that's one of the reasons why
we're on a completely different geometry all the time. Because the permanent signals might in fact be the thing you're working on as well. That's quite obviously very common.
Yes.
So this measures the crossing width for us, so that's 16.1 meters, and looks up the head timings, in this case from the TfL guidance, but you can set that back to chapter 6 if you'd like to do that. Again, this is all like speeding things up, but also making sure they're just correct, really, taking all the brain power out of the process.
And you've then got there's traceability built into this as well, because you know they was designed to this standard, and you've got all those metrics built into this to detail why those timings are being used, because it is this wide.
Exactly. And this was a recent addition of being able to draw gradients onto the road.
Okay.
And this is going to come in when we look at the intergreens next.
Yes.
Certainly for cyclists, especially when you think of cycling uphill through 150 metres of shuttle, that's sort of makes a huge difference.
Yes, definitely. And it's an aspect of intergreens that isn't thought about as much as it should, I think, even in permanent installation. So any tools that make it easier and provide it with more visibility, I think it is a really excellent thing to do.
And you can get the data if you go on Google Earth Pro. You can get a sort of fairly rudimentary, but certainly still useful measure of the gradient on a piece of road space from there. It's obviously not always practical, especially when we're running against short time scales to go out and literally measure an incline. But obviously you can see it to some degree on visually on the site. So so we've got that. We now know the scale of the map. We know the gradient of it, and we can then get to the intergreen matrix. So we select a cell on here, and effectively there's obviously various different options. We just draw a line on here to show the vehicle movement. You can put a manual intergreen in, which we generally wouldn't. A shuttle is where the traffic is in a shuttle working area, a certain point through that sort of vehicle path where there almost aren't really two conflicting movements. And this is obviously much more the way the Pink Book looks at red timing. So it's sort of a little bit thinking about the world that way.
But it's essential in that situation to clear that whole platoon of traffic through before you open up to the next movement. And it does happen occasionally on permanent sites, but it is something that is really far more related to portables, temporaries.
Yeah. So we have that style, and we can move around the the wakeboard at the end, and we can draw the line, whichever path we think the vehicles will take. And then we've got other types of integrine. It takes a little bit of skill to know which one to use where. That's sort of part of our internal training. But this is much more like a Chapter 6 style integrine.
Yeah.
And that's just the sort of nature of the geometry on this site. And we've got sort of an X distance between those two.
But it's taking account of those distances, it's using the geometry of it, it's using the gradient, and then the type of operation. So it's a much more comprehensive way of viewing these, I think, than a lot of people will be used to.
Yeah, what we're looking at right now is using the physics model that we presented at JCT, and we're sort of using that everywhere now. This is the model that takes account of the geometry and then the gradient, and also models different vehicle types travelling along those different lines.
Yes.
If we go back, which we can do, we can just untick. So we got at the moment there, we've got a 6-second intergreen. If I turn the physics model off, it's telling that Chapter 6 would have said 5 seconds.
Yeah. Which in itself doesn't sound a lot of difference, but if it results in a vehicle being in the wrong place.
Yeah, well, that's quite a short one. If we go and do the same thing on one of the longer ones, 17.
So, yeah, big difference there, and that could really end up with, best case scenario, the whole thing grinding to a really old mess.
And what I think we tended to find was we were going out using the guidance and then having to put sometimes quite a lot of extra manual correction, like 4 or 5 seconds onto things. And then what we've really realised doing the physics model is that we were probably only really catering for cars and motorised vehicles, because once you put a cyclist through there, you might think 27 seconds, that's just a huge number.
Yeah.
But when you look at a cyclist speed, that is genuinely how long it will take them to get through there at that speed. And we did add a facility, we can just bring up a plot, and this is showing what the physics model has predicted for each road user type.
Right. Yeah.
So it's not the most sophisticated model on the planet, but it's infinitely sort of better than just using distance measurements.
Yes.
The cyclist here dropping in speed is because we put that gradient uphill away from the mini roundabout.
Right.
So it slowed the cyclist down for going that part. So,
but that's the reality of the situation, and actually, users like cyclists in this type of scenario where the road space will be restricted because of the works, whatever they are going on, it becomes even more important because they won't have anywhere else to go.
That's well, you see that. You see them diving between the cones into the work site.
Yes.
It does happen.
Yeah, and that really is something that
Not good for anybody. Where they miss the fact that there's a trench there and they've sort of gone into it.
Yeah.
This is plotting against time at the moment, and we can see that literally the cyclist takes the longest. All the other vehicles have to slow down for the bend, but the cyclist can corner better at these sorts of speeds. So behind here, inside the model, is a sort of working knowledge of what speeds vehicles can do on different gradients, what's the maximum lateral acceleration and braking and acceleration characteristics. So we've got a full range of parameters in there. But we can plot this by distance, and now we're seeing all the vehicles at the same physical location slowing down for the bend that's in the middle of that sort of intergreen path.
But yeah, interesting to have those dynamics incorporated into this as well.
And then it's difficult to argue, I think, when you look at this and you look at this value of 21 and a half, I think seconds of red time is showing here. You can't really argue that. You'd have to argue that cyclists could go faster than this line, which as part of the research for this, I went out on my own bike and measured myself and concluded that these numbers were probably about right, if not actually a little bit sporting.
Yeah, because of course you do have a range of abilities with cycling as with any other
Yeah,
form
absolutely.
of user, um, but I think actually the people that need the most protection are those less assertive and less able members of the cycling community rather than the really fit and
We know one of them in this organisation.
but
But at
because
least one, yeah.
because they probably will have sped through in
Yep.
no time anyway. It's the others that
Well, if you're encouraging active travel, it's for everybody, really, isn't it?
it is, and actually that's a really good point because the whole issue about the change of the minority of users. We're looking far more about how we actually incorporate cyclists and pedestrians into these features that we're putting out on the road. So equally, with portables and temporaries, we've seen you never used to have head crossings at those, so that's a welcome addition. But also then thinking about these different capabilities, it really is important.
Yeah, absolutely.
Remember to hit subscribe for ITS now.
Actually, one other element of sort of design here, we can, because we know all the timings and how the product's going to run, we can show a timing diagram for the site. So that's particularly useful. But we can also run a facility that will explore different stage orderings.
Right. Yes.
To see if there's any sort of, which there can be, especially if any great savings in overall intergreen time. If you think you've got a long arm, a long shuttle,
Yes.
and then a junction at the end of it, the way round you run the stages can make a huge difference.
Yeah, reducing the wasted time, definitely. You want to get the used time in the cycle as high as possible.
Yeah. So that's sort of in there. So that helps us to be quick, because once we've drawn the intergreens, we've got the times. Those intergreen times are really the basis under which this optimization goes hunting for the best way to sort of get around the stages on the site. It'd be useful if I can just bring up a slightly different scheme to show you as well. So this is a site with a long shuttle arrangement with a junction at the end of it. Just zoom in a little bit, and we've used the we use the physics model for the intergreen times, but they're really long, and this is sort of a really high traffic site. And you think, well, yes, we want to be really friendly to the cyclists, but I can't run a 30-second intergreen to clear that shuttle. So what we've actually developed is having a.
So this is a shuttle working on a bridge over a railway or something.
It's sort of two bridges under a railway. Yeah.
Okay. Yeah.
It's in Greenford in West London. We have actually written a paper on this site that's probably covering some of the stuff we're talking about here. Yeah. But the key thing we've done is we put detection in the shuttle at both ends here.
Right. Excellent. Yes.
So we've got a pole with just a radar. We can also support some of the other AGD products.
Yeah.
We're starting to use the 650, which is really exciting for
sites. Having the AI platform on that's having the capability to implement a range of different features would be transformative, I would think, in some ways. So it'd be interesting to see how
it goes. And we've done things. We've done a dedicated cycle stage on a scheme using the 650 to spot cyclists. So things like that are sort of really powerful.
Yes.
But so what we've ended up here is where we've set the intergreens for this particular site So they're not as generous by default for the cyclists, but then we extend with effectively a clearance stage. If you look at the stages in here, there's this sort of, we're actually performing the same trick where we run the ped crossing next to the vehicle heads, but then this sort of phase E is kind of a dummy phase that does the detection and extends out that stage for any cyclist or any other vehicles really. And what we found running this scheme is, as well as hopefully looking after cyclists, it sort of avoids driver frustration, because people seem to get very upset by being presented with a green signal with traffic still coming out of the shuttle, because the sense is,
they've cheated,
and we've got to wait because you couldn't you couldn't wait at the red light. So the reality is, a lot of the time it's just a bit congested in the shuttle. And there's a sort of a bit of a change in direction at the end. Sometimes larger vehicles take longer, but because of this, you don't get that. You don't get green until the shuttle's empty. So you're kind of eliminated. It's a fairly minor thing, but it all adds up to frustration.
Because a lot of drivers will be frustrated in these situations, because even if it's working really efficiently, it's different to what they're used to, so they're having to think more about it. So if they think somebody else has taken advantage of something, it's not going to help.
This is a slightly more interesting scheme as well, in terms of there are sort of different phases in the conflict matrix, and if you look at our demands, there's a bit more going on there.
Yeah, I think there's a good example of overcoming, those particular issues on shuttle working, because it is something that will repeatedly be a problem. So having all the other capabilities that we've just talked about, but then also putting in the extra sort of all red detection in there makes a very powerful tool overall, and you can see it all on here, so it's really good. So I think, as a package, actually this has got a lot of innovative and critically useful features. It's not just toys for toys' sake. It is actually providing a lot of capabilities, and having the option on here to set up all the intergreens to scale, etc. So you're not having operatives aren't having to measure things on site and then try and work out numbers.
We had an example this morning where a site had been modified for emergency works, and we had to respond very quickly. So the whole intergreen matrix had to be potentially adjusted, but it took 5 minutes to do. So we just dragged some lines around, make a cross check, and the other nice thing we've built with this product is we send this configuration directly to the roadside over 4G. So the operative has got less buttons on this controller than any controller they've used before. It's just a load button where they load the scheme in. But they're loading something that's got an audit trail, vision history. The particular scheme they're loading's got a version. Every single sort of intergreen time and bit of configuration is sort of recorded away.
And again, they're not putting the wrong configuration into it manually, or either, back in the day they picked up the wrong EEPROM, or they picked up the wrong memory stick or something, and loaded it in to find that actually that was for the site. So it's totally different.
And portable signals, especially, for example, if you're under UTC control, you can find that an operative just decides that some more red time might be useful, puts that on there, and then breaks UTC control. So that's kind of the other reason for controlling it all from here, really. It's all done. We can make the Highway Authority aware of anything that's going to change and have them review it and sign it off. So that there are less surprises. I won't say no surprises, less surprises.
Particularly in these environments, like you're saying, with things changing, that's the sort of scenario that will happen repeatedly. But I am being able to reduce all of those failure points is really good.
Yeah.
But what you were saying about someone increasing a red period, I think there's a lot of lack of understanding how these sort of different layers of features within signal control actually operate with each other. And so, people watch the Italian Job, whichever version is your favourite, I don't care. But, think that you can just overwrite everything.
Do anything,
But
yeah.
that actually, there are these different layers of safety features built into traffic. And not always that they don't recognise how changing this could affect other features, or that actually it doesn't matter what you do here, you can't override those safety features.
Well, that's the thing, though, isn't it? In a permanent world, there have always been these layers of controls that different people get access to,
Yes.
according to who they are and what they're doing.
Yeah.
In the portable signal world, there isn't any of that.
No.
There is, do you have the key? Assuming the lights are locked, they're not always locked. Do you have the key? And that's it. You can do anything, and that doesn't really feel right, does it?
No, because ultimately, anyone can come along and just have a bit of a fit sort of it.
The law of unintended consequences is the thing we think of sometimes.
Oh, well, that's really interesting. I think that really opened people's eyes to how what was probably a slightly neglected corner of the industry is, this level of progress is fantastic. So thank you very much. Thank you again to Darren for taking the time to talk to me. To find out more about Signal Studio and Traffic Group Signals, find the link in the information below. And lastly, could I please ask you to subscribe to our channel? It really does help us to bring you further videos about ITS. Thank you again to everyone who has subscribed. Thanks for watching. See you next time.